friends, welcome back. Today you're going to want to grab your notebook and write this down. We're talking Saxon Algebra 1, Lesson 62. This is the third edition, the orange book. So, square roots. Here's what I want you to write in your notebook. Bam! This guy right here. The square root of something squared gives us x. Or the square root of something squared like this also gives us x. Essentially, the opposite of squaring something is to square root it. The opposite of squaring something is to square root it. The opposite of square rooting something is to square it. Just like the opposite of multiplication is division, or I should say the inverse of it would be, like the inverse of addition would be subtraction, right? So let's talk about this. So the square root of 18, round this to 5 decimal places. Now, first and foremost, we can estimate these, and I want to show you how to estimate those right quick. Remember, our perfect squares are 4, 9, 16, 25, 36. Make sure you memorize these. If you don't memorize anything else, memorize these guys. So when I take a look at this, I see that square root of 18, that's going to be really close to 16. It's going to come between 16 and 25. So it's going to come somewhere between 4 and 5. It's really close to 16 and not so close to 25. So it's going to be close to 4. It's going to be like 4.1 or something like that. Let's take a peek and see if we can get this on here. Okay, so what we're going to do is, I had to clear my calculator there. So what we're going to do is we're going to plug that into our calculator. We're going to say the square, whoops, let's try that again. Second, and then square root. So we say the square root of 18 is all of this. Now it says round to 5 decimal places. So we go 1, 2, 3, 4, 5. That's 4 there. Are we going to keep it as a 4 or round it up to 5? We're going to keep it as a 4 because the 0 next to it is less than 5. So we say that the square root of 18 is 4.24264, and that is 5 decimal places. Next example, round to 6 decimal places. So the idea for this one is, let's estimate this again. Square root of 10 is going to come between square root of 9 and square root of 16. It's really close to 9, right? So it's going to be real close to 3, maybe like 3.1. And I should back up and say, indeed, this was 4.2. I think I said 4.1, but I was off slightly. But you can see, you can ballpark that information. So this is probably going to be 3.1 because it's square root of 10. So it's really close to that. Okay, so when we do this, the square root of 10. So we got square root of 10, just like this in here. There we go. So let me write that number down. We get 3.16227766. We need to round to 6 decimal places. So 1, 2, 3, 4, 5, and 6 decimal places. So are we going to keep that as a 7 or round it up to 8? Well, because this is greater than 5 or greater, then we're going to round this up to 8. So our actual answer is 3.162278. Now, I have 2 answers here. So I have 2, sorry about that pause there. I have 2 answers here. And this is because whenever we take something out of the radical, it can be either plus or minus. Plus or minus. So we say positive 3.162278 or negative 3.162278. Now here's why. Let me do a quick side note here. If I have the square root of x equals 2, what do I have to put into here? Actually, that's not going to work quite as well. So if I do something like x squared equals 4. So let's think about this. In this case, what I can do is put in there either 2 or negative 2, because 2 squared equals 4. And quantity negative 2 squared equals 4, right? So if I square root this guy, and so if I square root these, I end up with negative. Probably hard to do positive or a negative here. So if I square root this cancels out, I get positive. And then if I cancel out that guy, I end up with a negative. So that's why we're allowed negative and positive. Hopefully I explained that okay. So that's negative and positive. Example 3. Oh, here are all your perfect squares through 15. Pause the video, write those down. This is 169. That's written kind of poorly. I always remember 13 squared 169, and then 14 squared is 196. So they flop around. That's a good way to remember those. Okay, so then example number 4 is going to be Okay, so example 3 just is writing all those down. That's good. I wanted to double check. No calculator, estimate the square root of 10. So remember looking up here, perfect square, 4, 9, 16, 25. This is kind of what I was doing above. Well, it's going to come between square root of 9 and the square root, which is 3, and the square root of 16, which is 4. So it's going to come somewhere between 3 and 4. The square root of 10 is real close to square root of 9. So I'm going to say like the square root of 10 is probably 3.1, right around there. And if you go back and we look, it's 3.2 if we're going to round to the nearest tenth. So we were really close in our estimate here. And it's just an estimate, doesn't have to be perfect. So that's how you take a look at those. Okay, cube roots, these are for your notes as well. Pause the video, write those down. You want to know that if the opposite of cubing something is to cube root it, the opposite of cube rooting something is to cube it. Same with your fourth roots. So these are opposite of each other. So that means when we have the cube root of 8 here, we look to see, well, the cube root of 2 to the third power would give us 8. So these guys cancel out and I'm left with 2. So the cube root of 8 is 2. Now the fourth root of 81. So here's our fourth roots right here. And you see 3 to the fourth power is 81. That's 3 times 3, which is 9, times 3, which is 27, times 3, which gives us 81. So this would be the fourth root of 3 to the fourth power. These guys cancel out, and I'm left with 3. What about the cube root of negative 27? So if you have an odd radical here, you are allowed to have a negative. I cannot have negative 4 like this because the cube root of that is the only way I can do that is 2. And like I said before, if I do negative 2 squared, that gives me 4. So there's nothing I can put into here to get out a real number. You'll talk about imaginary numbers or complex numbers in Algebra 2. So for right now, this is just no solution. However, with a cube root, we can because the cube root of, and we look to see, remember, 3 to the third power is 27. If I do negative 3 to the third power, little side work here, negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. So quantity negative 3 to the third power is the same as negative 27. So you can see I've rewritten this. So those cancel out and I'm left with negative 3. All right, let's take a look at this guy. We have negative. So this one might be a little bit easier if you see it written with a different color. So we have negative and then we have 2 squared, this guy right here, which is 4. Then we have plus quantity negative 3. So we did this part right here, and then we're going to do this. Quantity negative 3 squared is a positive 9 plus minus the square root of 4 is 2. So we have two things here. We have negative 4 plus 9 plus 2, and we have negative 4 plus 9 minus 2. Over here, if I gather up, or if I like to gather up my positives, gather up my negatives. So I get negative 4 plus 11 because 9 and 2 are positive. And so that's going to give me positive 7. Whoops, my bad. Positive 7. Over here, I'm going to add the opposite. Gather up my positives, I get 9. Gather up my negatives, I get negative 4 and negative 2. So that's negative 6. And I get positive 3 is my solution. Okay, let's do the practice problems now. So for your practice problems, go ahead, pause the video, do these, and then come on back. All right, so the first one on our calculator, if we plug that in, we end up with 4. So this is approximately, and I use those little squiggles for approximately when we're estimating, and non-perfect squares you're estimating because it doesn't repeat, doesn't end. So this is approximately 4.123105. If I wanted you to round this to the nearest, usually the 100th or 10th is fine. So let's say the 100th. If I wanted you to round that, do we keep it as a 2 or round it up to 3? We're going to keep it as a 2 because this is less than 5. So our answer would be 4.12. So 4 and 12/100ths. No calculator. Okay, so remember our perfect squares are 4, 9, 16, 25, 36. Aha, 27 is going to come between 25 and 36. So we have 25 and we have 36. Now remember, 25 is 5 and 36 is 6. So right in between there, 25, 27 is probably like right here. So maybe it's 5.2. I would estimate about approximately 5.2. Now, if we were to plug that into a calculator to get an exact answer here, we would get 5.196. So yes, 5.2 is our correct answer. The cube root of negative 27. Remember, negative 3 to the third power is negative 27. So I've just rewritten this to use my exponents, and then I can cancel, bam, bam, cancel those out, and my answer is negative 3. What about the square root of 81 minus the square root of 144? The square root of 81 is 9 minus the square root of 144 is 12. Add the opposite and we get negative 3. Okay, so then we've got this one down here. We have negative, and then remember we do our exponents here and then we slap on a negative. So negative 1 plus quantity negative 2 squared is going to be positive 4 because it's negative 2 times negative 2. Positive 4 plus minus the square root of 9, which is 3. So negative 1 plus 4 is going to be 3 plus minus 3. So we have two things here. We have 3 plus 3 and we have 3 minus 3. 3 plus 3 is 6. And 3 minus 3 is 0. Okay, so any questions? Let me know in the messages below. And I just realized too, on B it says no calculator. It just said tell me what two integers does it come between, 5 and 6. You don't actually have to do the estimating part. I just like to show you that. So the correct answer is really just 5 and 6. But like I said, if you have any questions, leave those below. Otherwise, great work, and we'll see you next time.